Tollens reagent. Now let me talk about this Tollens reagent as well as Fleming's or Benedict's reagent. Okay, Tollens reagent, Benedict's reagent, and Fleming's reagent all do this. They help you to enable you to identify aldehydes or alkanals. What Tollens reagent is a solution of silver diamine, AgNH3 twice 1 plus. Okay, that's silver diamine, and that's in aqueous solution. What that does is, if you take a solution silver diamine and you add a drop or two of the compound that you're testing to see whether it is an alkanal. This species here, this silver diamine, is a mild oxidizing agent. It is sufficiently strong to oxidize aldehydes to alkanoic acids. And when that happens, the aldehyde gets oxidized to the alkanoic acid and the Ag plus gets reduced to silver metal. So if you had a very clean test tube that you were using and carried it out carefully, hopefully you'd get a silver mirror forming on the bottom of the test tube. So it's also called the silver mirror test for an aldehyde or alkanal. We use Tollens reagent, add a drop or two of the thing we suspect might be an alkanal, shake it, and you don't need to shake it actually, otherwise the silver mirror will come off, and you'll see a silver mirror forming on the bottom of the test tube. Sometimes the silver mirror doesn't form, it actually just precipitates like gray colored silver metal down the bottom of the test tube. Either way, that confirms that it's an aldehyde. The other ones that we can use for the same test, Fleming's reagent. Now Fleming's reagent is a solution containing a complex ion of copper 2 plus. That's copper 2 plus tartarate. Tartaric acid is an acid, and you take the copper 2 plus tartarate and in a solution of sodium hydroxide. So that's Fleming's reagent. And when you add a couple of drops of the compound that you suspect to be an aldehyde, the copper 2 plus in there gets reduced to copper 1 plus, and with the hydroxide ions in the solution, it produces a brick red colored precipitate. Okay, if they ask you what's that precipitate, that's copper 1 oxide. So the copper 2 plus ions in Fleming's reagent, it's not as free copper 2 plus, it's copper 2 plus complexed with the tartrate ion. You don't need to write the formula of that, right? But it's copper 2 plus, which then gets reduced to copper 1 plus and produces copper 1 oxide as a brick red colored precipitate. Right, finally, Benedict's reagent does the same sort of job as the Fleming's reagent, but rather than use copper 2 plus tartarate, you use copper 2 plus citrate, and you use sodium carbonate solution to acidify it. Again, it's a brick red colored precipitate that you obtain if it's an aldehyde.